the unit vector perpendicular to each of the vectors 3i plus j plus 2k and 2i minus 2j plus k. So if we solve it in the examination hall, how will you do this? You'll write it as I, j, k. Then we have 3, 1 and 2, right? And we have 2, minus 2 and 1. If we open this, I will have these two. So I into 1 into 1 is 1, 2 into minus 2 is, 2 into minus 2 is minus 4. So it is 1 minus minus 4 is 1 plus 4, right? 1 plus 4 minus j into, so while we do j, we get 3 into 1 is 3, 2 into 2 is 4, so 3 minus 4 is minus 1, right? Plus k into 3 into minus 2 is minus 6, 2 into 1 is 2, 6 minus 2 is minus 8. So what we get is 5i plus j minus 8k. So this is the vector that we're looking for, and there is only one option with 5i plus j minus 8k. That gives the correct answer. It's less than 1 minute to do this question. But please don't stop here, because what happens is, if we calculate the magnitude, some of the so 5 by, there is no probability that any of the terms will get cancelled here. So the only possible option, and in fact the correct option, is 5 plus 8j minus k. And what is the magnitude? The magnitude will be root of 5 square plus 1 square plus 8 square, which is root of 25 plus 1 plus 64, which is root 25, 6, 30, 26, 60, 90, which is actually 3 root 10, right? Okay. So since we found a 3 root 10, and the answer is now that we have the answer, I would suggest, let us try to look what the question is actually about. See, this is actually a very beautiful question, because it is not the answer that's beautiful, but the demand of the question that makes the question really beautiful. Because the question is not to find out the unit vector perpendicular. The question is actually asking you to define cross product. And how is that? Because we know that by definition, cross product of two vectors, say for example, cross product of two vectors, vector A and vector B, is another vector. Cross product of two vector is another vector, vector C, which is perpendicular to both, vector A and vector B. So when the question asked about unit vector perpendicular to each of the vectors, it was actually asking you to find out the cross product. Now let us just spend a couple of minutes to actually understand what this unit what is the concept of cross product that we're actually talking about. See, when we have vector, let us take an inclined one. Say for example, if this is vector A, okay, if this represents vector A and if this represents vector P, then what is the cross product? It is another vector like this, right, which is perpendicular to both these vectors. So this vector C, is what we call as vector A cross vector B. Now another thing what we need to understand is, say, and how do we make an okay, let's say one more thing and we'll be done with it. Let's say we have vector A here, right, vector A, and say, okay, let us take this vector B. So this is vector B, this is vector A. Now say, what is this? This is This is A cross B. Well, actually, this represents A cross B, the direction of A cross B. And we know that this vector is perpendicular to both the vectors A and B. Now, what is the magnitude of this A cross B? See, that is obtained by drawing a parallelogram using the other two vectors, vector A and vector B. Okay, so if the angle between vector A and vector B is theta, then this parallelogram completed by joining the vectors containing this angle theta is the magnitude of vector A cross vector B. So it means that this shaded region, the area of it will actually represent the magnitude of A cross B, and it is this magnitude that we calculate algebraically using the method of determinants. Okay, so that is one more thing about cross product. Okay, one final thing and then we are done. So let's say this is vector B, this is vector A. Now what is this? This is vector A cross vector B, and we often see this in the definition of cross product. We see a unit vector. So this is that unit vector n cap along the direction of vector A cross vector B, and we can also have another vector here. Can you guess what would that be? This vector is what we call as vector B cross A, or this can also be expressed as minus A cross B. Okay, so this is it about cross product and the analysis of it. So always keep this in mind. Two vectors in a plane, right? In a plane, another vector perpendicular to this plane in such a way that the vector is perpendicular to both the given vectors. It represents the direction, unit vector along that direction, and opposite to that, what we get as B cross A. So A cross B, A B in the reverse direction, B cross A, right? Okay, so and always try to visualize this in 3D. See, all of this basically takes place in the three-dimensional axis. That's how it if you can visualize these things in 3D, you'll understand the concept of A cross B or cross product better. So is there anything else we should add here? Maybe when we see another question. So let's now move on to the next question.